In today's video, we're going to focus on the quotient rule and higher order derivatives. So let's look first at the quotient rule. Quotient rule you use when you're dividing two functions, and both functions need to be differentiable, and the bottom function, g of x, cannot equal 0. I want to find the derivative with respect to x of f of x divided by g of x. I would do the following. That is equal to the g of x, which is the bottom function, times the derivative of f of x, or the derivative of the upper function, minus the upper function, f of x, times the derivative of the bottom function, g prime of x, divided by g of x squared. One way I can always remember this is low d high minus high d low over low low. Low d high minus high d low over low low. Okay, let's try a few example problems to see how the quotient rule actually works. So looking at this problem, my low is 5x to the 5th plus 2, and my high is x to the 5th. So low d high, so the derivative of the top, which will be 5x to the 4th, minus high, x to the 5th, times by d low, or the derivative of the bottom, over low low. So that's the bottom quantity squared. After applying the quotient rule, all that's left to do is simplify the expression using our algebraic rules until we get our derivative. In example 2, we're going to start with the same rule. So our derivative is equal to low d high minus high d low all over low low. Simplifying with algebra, and we find our derivative. For example 3, let's try taking a binomial divided by a binomial and find its derivative. So low d high minus high d low over low low. Using algebra, simplify the numerator. Combine like terms. And the derivative of g of x is equal to the following. Our last quotient rule example, let's try finding the derivative of y. This is a polynomial divided by polynomial. We'll start with the quotient rule. Low d high minus high d low over low low. Simplify using algebra. Afterwards, we'll combine like terms. To find our final derivative answer would be 12x to the 5th plus 24x cubed minus 12x divided by 2x squared plus 2 quantity squared. We're going to look at higher order derivatives, and that's just simply taking the derivative of a derivative. So what we've been doing is we've been finding the first derivative, which is the derivative of our original function, and we've called that y prime. Now remember, we have many notations for a derivative. So y prime, f prime of x, dy dx, derivative of f of x with respect to x, dx of y, is all notations that we can use for the first derivative. Higher order notation is very similar to those. So our second derivative is y double prime, d2y of dx2, etc. Our third derivative is y triple prime. Fourth derivative, notice that we put the 4 in parentheses because it gets too confusing if we try making too many slash marks. And we can continue that pattern for as many derivatives as we need to take. For our first example here, let's find the second derivative of the function. So our original function, let's differentiate that using our power rule. And then we're going to take the derivative of the derivative. So differentiate yet again with the power rule. And we find our second derivative is equal to 48x squared. In example 6, we're asked to find the third derivative of the function. So that means we're going to differentiate 3 times. So we're going to take the first derivative by using our power rule. Then we're going to take the second derivative by using the power rule again. And then the third derivative one more time, differentiating the function. Let's go one more higher. This time, let's find the fourth derivative. So we start by finding the first derivative of the function using our rules of differentiation. Then we find the second derivative by repeating the process, the third derivative, and then the fourth derivative. Notice that I put the 4 in parentheses. Make sure you remember the parentheses in your notation. In the last example of the day, let's find the third derivative of this function. So given that y is equal to 2x to the fourth plus 3x cubed minus 5x squared plus 11, we're going to find the first derivative by using our differentiation rules. We get 8x cubed plus 9x squared minus 10x. Then we're going to find the second derivative of the function, which is 24x cubed plus 18x minus 10. And now we're going to differentiate one more time for the third derivative of the function, which would be 48x plus 18.